Good afternoon, everybody, and thank you for joining me today to hear about my OCR model and corpus for the detection and transcription of Berber signs. To start with some background, Amazigh, Tamazight, and Berber all refer to the same language family, which is a low-resource North African vernacular language spoken in Morocco, deriving from the indigenous Berber ethnic group. It has its own alphabet. Berber is still widely spoken, yet lacks adequate representation in research or web applications. Metrics put active fluent speakers at between 15 to 33 million people today across countries like Morocco, Algeria, and others. Modern-day Moroccans are largely multilingual, with Berber being spoken in rural homes of Morocco as well as in the cities, but rarely ever written, as Moroccan Arabic is widely spoken and the dominated writing system. French is essentially required for working in businesses or research. Because of the trilingual nature of the rural areas, road signs and business signage can be found written in 3 languages, each with a different character set: Berber, Arabic, and French. So this is an image that's an example of a sign that's trilingual. So on the top banner in the dark blue, we can see Arabic. Underneath it, Berber or Amazigh, and as well as French on the bottom banner. Here's another example of a road sign that's transcribed into 3 languages. So this is called Tifinagh. That's their word for alphabet, and these are the unique characters that you are seeing. Many of them resemble some things we see in the English alphabet. Some of them resemble things we see in other languages, such as Greek and Russian. So some more on motives and research incentives. Signage listing local businesses or upcoming destinations, like the last picture shown, is a common piece of language data that is observed by all self-driving vehicles, yet is not widely processed. Semiotics can be a very valuable piece of data in the future of vehicular AI. Added capability of detecting and recognizing street signage in the future of the self-driving car market can improve directional sense and AI awareness capabilities. Past that, we're also looking at machine translation, language acquisition apps akin to Duolingo, and since signage lists the names of destinations and towns or businesses and may not be concerned with necessarily previous and forward context in the same way a sentence would, and grammaticality and things like that. Character-to-character detection with this pictorial script can be performed in a similar way to handwriting recognition CNNs, which is sort of how we modeled our research setup with the pre-processing as well as the choosing the model. Another interesting point of the corpus which we self-created was that some images could be scraped from using Google Street View, which was especially useful since these are taken from a car's view. And in this image, you can see that even in the natural environment, one of the challenges to face is that depending at the moment the photo is taken, or if you're using a live feed, that moment right here is being obstructed by something that's out in the wild. So something like a handwriting recognition model wouldn't really have to deal with this. So an image on the left is an example that is in the corpus that's taken from Google Images. This one's unique because these letters actually cast a shadow under them. Once again, trilingual in Arabic, Berber, and French. And a lot of the photos, since there are a very low amount available between Google Bing and Google Street View, with this just being a low resource language, a lot of the photos I have taken myself, specifically looking for signs in Berber of different styles while I was in Morocco. A large portion of the photo is a sign. If it's not a sign specifically, it's something that would still be read by a vehicular camera feed. So it could be text inscribed on a building. But these 3 images show signs, the first one being trilingual and the second one just showing Berber and French with different destinations, and the third one a sign for the airport. So eventually, Google Drive was used to house these images in their raw form, and 120 images were gathered before they were broken down into their character level. So the flow of the data basically went from the input from camera or gallery, hand extracting these characters from the images, pre-processing these images, feeding them into the OCR VGG16 model, which is then giving predictions on which characters they are. The 120 images that were in the original corpus were broken down into 1,862 character images, which spanned across 33 Tifinagh, which is for each letter of the alphabet, character folders. An interesting observation on the character occurrence imbalance: some Tifinagh characters appear much more frequently than others in roadside signs. So the top three largest characters in the images constituted for over 1/3 of the entire character image corpus. So that means the top three most frequently occurring letters constituted for 34.3% of the corpus. In turn, the lowest three constituted for a very small percentage of the corpus. For example, the emphatic Z, which is separate from the normal Z noise. English doesn't produce a separation between these two or have emphatic characters that are marked differently in our alphabet, only occurred 0.37% of the time. That's because it's only really included in some words that might appear on signs, but not necessarily within any towns or states or stuff like that would be in signs. So eventually, these 1,862 characters were put in their respective folders. These were the folders for the letters of D, F, L, M, W, Y, and Z. And we were able to achieve 92.2% test accuracy using the VGG16 model with the architecture pictured on the left, the accuracy chart on the bottom right. And to benchmark our results, we wanted to run the same model on a different set just to make sure that our claims that it's more difficult to do this in the wild are substantiated, where we found 98% plus accuracy using the AMHCD handwriting recognition dataset, which is Berber characters handwritten. We also benchmarked using LLMs to see if this would improve accuracy. Using Tesseract, we were able to achieve 98% accuracy with the Arabic and French PLMs on Arabic and French words that were in the corpus. Unfortunately, a large language model does not yet exist for Berber, but even the text that's in this corpus, their outputs can work towards some type of geographically fine-tuned data set. So possible applications, as I mentioned before, language acquisition apps, camera feed technology to identify the alphabet for early stage children or travelers for road signs, and other pedagogical applications that can provide education, as this corpus is a step into allowing the NLP collective for Berber to be where it should be. And for future work, we want to continue to expand the corpus as well as test with other models. And 10 mirts, which means thank you very much for listening to my presentation. And this is the Works Cited. So thank you again, everybody.